It is one of the strangest facts of science today that we really don't know what matter is. We all think we know what matter is. It's the hard stuff. It's what we are made of, what we sit on, what we breathe and consume. For a great many, matter and the forces that control them are the only real things in the universe. But even the forces are matter. For example, the celebrated Higgs boson, finally discovered in 2012, is a particle understood to give gravity to other particles. So it is matter. Matter always, matter everywhere, and nothing else, at least in the physicalist view. So how can it be that scientists can't agree on what matter really is? As one scientist said recently, if you ask 10 philosophers what matter is, you will get 11 different answers. The story of science is largely the story of the search to understand matter. Some of the earliest thinkers who we would consider scientists were Greek philosophers. About 500 years before the birth of Christ, Leucippus and his student Democritus taught that all matter was made up of small particles they called atoms. Atom was a Greek word, meaning something that couldn't be cut or further divided. Everything was made of these undividable bits of matter. About 300 years before that, a philosopher in India by the name of Aruni said that particles too small to be seen mass together into the substances and objects of experience known as kana. Across the globe and across time, we have always thought of the stuff of the universe as made up of particles, little hard things that come together in obedience to the laws of physics. They form the wide variety of substances and things that we experience in this universe. If everything is made of particles and forces that control them, then to understand our universe, we need to know more about those particles. And we've learned an amazing amount. Now we have massive, multi-billion-dollar tools that allow us to dig ever deeper into the mysteries of matter. The Large Hadron Collider is the largest machine in the universe. With tremendous speed and force, it smashes particles together, and scientists study the results of the collisions. That's how the elusive Higgs boson was discovered on the 4th of July in 2012. Cue the fireworks. Everything that scientists have learned about matter so far is encapsulated in what is called the Standard Model, developed in the 1970s. By continually looking deeper and deeper into how matter is constructed, physicists have determined that there are matter particles called fermions and force particles called bosons. Matter particles make up the elements of the familiar picture of the atom, with its nucleus of a proton and neutron and its electron buzzing around. Protons and neutrons are made up of smaller particles called quarks and leptons. There are 4 fundamental forces that act on these matter particles. 3 of the 4 forces are carried by particles called bosons. The photon, familiar to us as the particle of light, carries the electromagnetic force, the weak force by the W and Z bosons, and the strong force by the aptly named gluon. One thing we have learned about all these particles is that while they make up what we consider real in our universe, the matter we perceive as hard, impenetrable, and real is actually far from it. Nothing in matter, it turns out, is really solid, and atoms are almost all empty space. To understand this, think of a large football stadium. The nucleus in this atom is the size of a picnic basket placed on the midfield or 50-yard line. The electron can be seen as something the size of a fly, circling around the nosebleed seats at the outer edges of the stadium. The space between the nucleus and circling electron is empty. So when these atoms come together to form things like concrete on the sidewalks we walk on, or wood and leather on the chairs we sit on, why do we not just pass right through? We're made of atoms as well, so we too are mostly empty space. Why is there any sense of solidity at all? Wolfgang Pauli, one of the brilliant early pioneers of quantum physics, determined that fermions, the particles that make up matter, cannot have the same quantum numbers. That means they can't inhabit the same space with other fermions. There may be lots of empty space, but that space is protected by the very nature of the particles. Bosons, which convey force, are different and can occupy the same space. This realization explains much about matter and forces and how they come together to create what we see as reality, and it explains why we don't fall through the sidewalk or our chairs. All of this great science would lead us to conclude that we do indeed know what matter is. But the strange fact is that the more we have learned about it, the more the mystery of matter deepens. That's why it is very reasonable that based on all this knowledge, philosophers and scientists can't come close to agreeing what matter really is. There are two major reasons for this. One is what we have learned about matter in quantum physics, and the other is consciousness, or our minds. We'll look at quantum physics first, then consciousness. In the 1920s, scientists centered around Germany and Denmark made some profound and deeply shocking discoveries about matter. Scientists understood magnetic fields and how electricity travels through fields, coming up with the mathematics for the electromagnetic force. This force takes the form of a wave. A wave carries energy dispersed over potentially wide space, and it features peaks and troughs at certain intervals called frequencies, and wavelengths or distances between the peaks. Light arriving from the sun or a candle followed the rules of a wave or electromagnetic energy. But there was a problem. Individual units of light called photons also seem to behave a lot like a particle, like other particles, like something not spread out all over, but here, in one spot. They conducted an experiment called the double slit experiment. It should have settled the issue. Was light a wave or a particle? But instead of resolving it, the experiment revealed the uncomfortable fact that it was both. How could it be energy spread out in the form of a wave, where it is simultaneously here, there, and almost everywhere, and a particle like a grain of sand or a bullet located precisely here? That's just the beginning of the mysterious nature of matter that we will explore in the next video. But first, what about the other reason for disagreement about what matter really is? Consciousness. We think, we feel, we have ideas, we experience all kinds of things. What is a thought? What is an experience? Are there particles that we can identify as thoughts? Can the color blue be captured in the mathematics of a wave? Is experience reducible to particles? Some say, if we can't understand consciousness or our minds in terms of matter and particles, it must mean they don't exist. Those who think this are called eliminativists. We've talked about this in an earlier video on the 5 categories of consciousness in today's thinking. For most of us, we accept that our minds are real. Some believe they are the only things that are real. It is true that the way we know anything about matter is through our senses and our brains. We see, we observe, we build technology to expand our senses, and we test, experiment, and come up with ideas and theories. That is how we know what we do know about anything outside of us, including the entire universe. But how can we know that what our limited senses allow us to experience and our brain processes thinking about these things can come up with the truth about what is real? In other words, we can't know for certain based on the equipment and knowledge we have. But since we know our minds are real, maybe our minds, or mind in general, is all there is. Maybe our minds conjure up the perceptions of matter, of the desk, the chair, the sidewalk. Maybe perceptions or experience is all there really is. We can see these very different ideas about matter and what is real as 2 poles. The South Pole is scientific realism, which says that there is a reality to matter in the universe even if we do not observe it, that the moon is there, whether there is anyone to take notice. The other, the North Pole, is called idealism. It comes in many different versions, but most are based on the idea that the mind or consciousness is primary, and whatever matter may be, its reality is determined by our minds, and maybe exists only in our minds. It would be simpler if we could say that science tells us that particles of matter are real and exist whether we are looking at them or not, and that it is religion, philosophy, or faith that tells us matter is a mystery. But It's just not that simple. Physics is telling us that matter in the form of particles or specific locatable properties only exists when it is observed by a mind, a conscious mind. Now you see why there is so much up in the air when it comes to reality and the nature of matter. Science and religion seem to be coming together in the quest for the most basic question of all. After all, we are made of matter. If we don't know what matter is, how can we truly know who and what we are?